Hello everyone, welcome back to RCH Builders. A question that I get a lot is knob and tube wiring or cloth wiring illegal? The actual technical answer is no. It's just like changing the oil in your car. It's not illegal to not do it, but if you don't do it, you're not maintaining the system, and if your car blows up because there's no oil in the engine, then you can't expect the insurance company to buy you a new vehicle. So it works the same way with the knob and tube and the cloth wiring. If you do not maintain the electrical system in your house, then the insurance company will use that as an excuse. Oh, well, your fire was caused by an electrical issue and you had knob and tube wiring, which is out of date. It works the same way. It was a system that was not maintained, so they will essentially pay to replace a lot. Sometimes what they'll do a technicality. They'll pay to replace knob and tube wiring, which is so far out of date that they basically give you nothing in the end. Just like all other items, they derate it at a value based off how many years old it was, and by the time you're done, they owe you nothing. So it's something that you want to upgrade as needed. As well. What is illegal, and I see a lot of times, is when you will have a guy, sometimes a homeowner themselves or a handyman. I also have seen some electricians who will do it, and it is illegal to modify the system. If you are not allowed to touch it, as long as it already exists, it is under the grandfathered in rules that we discussed in the previous video on load bearing. It already exists. They won't make you upgrade it, but you are not allowed to add to it, and you are not allowed to modify it in any way. I've seen people, they'll strip it back and they'll wrap a new Romex wire, split it and wrap it around the wires. That's not good. Knob and tube wiring, at the time that it was put in, it was in the 1880s to the 1940s. And at that time, you didn't have refrigerators. Toward the end of it, there may have been a few people who could afford to have a small refrigerator or a freezer that was a newer item at the time. But for the most part, they didn't even have, no computers, no vacuum cleaners, no nothing like that. It was simply a system that was designed to put lighting in the home. With that being the case, if you're just running, and typically it was one light in the middle of the room or a lamp that plugged in at the wall, and it was a small 60-watt bulb. They weren't even really going to have anything like a 100-watt bulb that we have these days. So as far as the amount of power that was being pulled through the knob and tube, it was not a lot. All those panels were 60 amps anyway. That's all they were designed to operate off of, 60 amps only, which again is not a big deal. The other thing with knob and tube is every circuit in the entire house shares one neutral. As long as you have two circuits, which is more of an older style as of wiring, even today it's considered out of date. But within the last 5 to 10 years even, it was common to share a neutral between two circuits, or even three if you're in a commercial situation where you have three-phase. The reason being is because alternating current operates on a one-off, one-on circuit. Now, it does it at 60 hertz, so it's extremely fast, 60 hertz per second. Essentially, when the first phase is running, the second phase is not. So at that point in time, circuit number one is running and using the neutral. At that very same time, circuit number three, because that's the way they are in a panel, 1, 3, 5, all on the same side. 1 and 2 are actually on the same, they're on the same phase. They're across from each other in the panel. But so 1 and 2, 1 and 3, when 1 is on, 3 essentially is off. So it is not using the neutral right then. Now, it happens so fast, but that is what helps keep the neutral from overheating. Now, in an old knob and tube system, because it was new technology, It was fairly new. They didn't even understand necessarily fully about that. And on top of that, again, they were just running a few lights here and there. So it wasn't necessarily considered a big deal for them to have only one neutral throughout the whole house. So actually, they didn't even understand fully about that. So with that, if you're adding on to knob and tube wiring, you are exacerbating that issue that there is. It was between the 1920s and the 1960s that they started running cloth wiring. You have two wires together, the hot and the neutral, both running through the single combined cable. At this point in time, it's getting closer to what we have today. However, if you look at the sheathing, it is braided, and it is technically made out of like a cloth material. That's why I refer to it as cloth. The knob and tube also has a cloth sheath over the top of it, but because it has the knobs and the tube system of wiring it, that's typically the way we refer to it to keep them from being confused when we're talking to different people and talking about it. So the cloth wiring, it had a hot and neutral. Most of those were ran through a larger fuse box. Typically was still only a 60 amp. They didn't have computers still. It was more common for people to have a refrigerator at that point, but it still was running minimal electricity. Usually ran through a 60 amp panel. They did start to have electric stoves then and dryers. So those were the large pulls on there. However, the stoves and the dryers, they used what was considered a ground instead of a neutral. However, because of the way that the electronics would run in them, they were set up as a timer. So the timers that were inside them at that time, they were 240. They were a dual phase system. These days, you should not have your stove or your dryer set up without a neutral. The reason why is because, again, back then, all of their timers were 3-phase. Now everything's digital. It is ran through a neutral. And essentially what they do when they hook it up to a 3-phase, they use the ground as a neutral, which, because they kind of go back to the same things, eventually it's not the biggest thing, but it does make it easier for someone who's trying to work on it, or if there's a fray in the line anywhere, for there to be an issue where something can get touched against a essentially live wire. Because when the neutral is being used, it is live, versus a ground who is supposed to be dead at all times. The only times the ground's supposed to have any power on it is if there is an issue, and then it's supposed to trip out, and it's supposed to take that electricity safely to the ground. Back then, again, everything was 240. They did have stoves. Some people had dryers, but again, it was very few people who could afford that. It was still a 60 amp panel. Sometimes there would be a 100 amp panel that was used for that added usage. Most heaters were going to be gas or wood burning. So you still didn't have that on those systems either. Again, there's no ground in any of those systems. The only time they ever had a ground was for like a stove or a dryer, and they essentially used it as a neutral as opposed to a ground. About the 1960s, so if you do electrical a lot, you can pretty much date the age of a house based off the wiring that is inside it, because you just learn different time frames of when different wires were used. So in the 1960s to about the later 1980s is when they started coming out with and using the first version of non-metallic cable, or what most people refer to as Romex. Now, that version also did not have a ground. The only times they had it, again, was for a stove or a dryer, something of that nature. And like same thing as far as during the cloth era, it was essentially used not as a ground, but more as a neutral. At least it's a little bit safer. The thing with the cloth and the knob and tube is it is very easy for squirrels to eat, gnaw on them, and get them frayed, and then they're damaged. Also, because they're cloth and they get frayed easily, you should not insulate around or over them. So if you're wanting to fully insulate your attic or your crawl space, you should get your wires upgraded, because with them being a cloth material as well, the electrical overheats up, and it needs to be able to let that heat disperse. If it can't disperse and it's all held around there, then it's like holding, I mean, if you do any little kind of fun experiment type stuff, you take a battery and hold a battery up against some cloth material that is slightly damp or whatever, and you hold it there long enough, you can light it on fire. You're going to do the same thing with your wires. With the non-metallic, when they came out with the Romex, it at least is essentially a little bit safer as far as that goes. But again, there's no ground to protect anything. It's not usually going to be the worst case scenario. The issue is a lot of times, again, it was only a 100 amp panel. People added on. A lot of times when they'll add on, they do not add onto it correctly, making sure it's all inside junction boxes, and there might be too much stuff on that one circuit because it also at that point was not designed for all the electronics that we have now. Towards the late 80s and until now, they have gotten more and more consistently different versions of Romex. One of the Romexes that came out in the late 80s does have a ground. However, it is a lot smaller than the ones that we use now. The grounds that we use typically now are going to be the same size or just one size smaller than the other wires that are inside the combined cable. When they first came out with the idea of it, they ran one, so you might have like a number 12 wire, which is fairly decently sized, probably about the size, trying to think of something in relation. So probably around the size of like a large, one of the really large pencils, the big round pencils, about that size. The ground that was at that point was going to be more like the size of a needle. It's extremely small. Still, at least it was something, but it was just different times. It was around the 1990s when they have pretty much the same wiring they have now as far as Romex. Not much has changed. Just depends on who you get it from as far as manufacturer. Sometimes the Romex is stiffer, sometimes it is more flexible, but at least everything that's around there is of a material that can withstand the heat. Of course, if you have a short, it can still cause a fire, but it is more, it's like you trying to start a fire with plastic and a minor heating item. It can happen if it is concentrated for long enough, but it is much less likely to happen than a very dry piece of cloth. Another thing that we have changed a lot now is not common anymore to have a neutral shared between any circuitry. And the reason for that is because we have so many small electronics that we use now in LED. If you share a neutral between two circuits, the small amount of electricity that runs through the neutral after going through whatever you're using, from say you're running a vacuum on one circuit and the other circuit that's sharing that is your lighting circuit, it is going to create flickers. If you have the light off, it essentially, you will see that the LED bulb is still glowing. It will look like it's running because it technically is. It's being backfed through the neutral. It is enough power to operate the small amounts of electricity that we run our equipment off of a lot of times these days. So because of that, it is no longer considered common or essentially safe, really, for your equipment. It's not typically going to start a fire. It's not going to cause any issues like that, but it can burn up your little diodes and stuff like that that are inside all of our small equipment that we use these days. It's just a difference in timing. Sharing neutral, like I said, it creates backfeed. Back in the day when that stuff was much more operated on larger amounts of electricity, it wasn't really going to burn up really anything. It just wouldn't work. With our smaller items, it can run at such a low amount of electricity that can really mess something up. In that case, now we do not any longer share neutrals. You'll still find it in a lot of houses, and it's not usually going to be the worst case scenario. But if you have a light acting like it's on when it's all the way off, that's actually usually what's going to cause it. Is there's a neutral being shared somewhere, and when you turn on a certain other item, or just say you've got your light in the bathroom that keeps doing it in your master bathroom, it could be because you got your TV plugged in. It can be something as minor as that. It's not a big deal, but it can be an annoyance is all. Hope this helped you understand a little bit about different time frames of wiring and why you should possibly upgrade. Oftentimes I get comments as far as, well, I just want to know if my wire is safe. Is my house going to burn down? I can't answer that. It's legal reasons. I can go in, I can look at your wiring, I can see that there is no phrase anywhere that I can see, but I can't see inside the walls. And I can't see what other people have done, because I've gone in and ripped walls out, and you'll see that somebody tied to the knob and tube inside the wall and then buried it. I can't tell. So essentially, I can't say. All I can do is look inside someone's house and say, as far as I can tell, your wiring is up to par from when it was done. That is the best that can be said. If there's any changes, I can't make changes to it. I would have to add in another circuit and go from there. And that unfortunately has made some customers a little upset, because they want to just add an outlet on a wall, and by law, you cannot do that. That is illegal. Them having the knob and tube, I can't make them change out the outlets they have, but if they want a new outlet, that outlet needs to come from a new up to code source, or it would be illegal. So legally, it may not be illegal what you have, but it would be illegal for me to add on to it. Hope y'all enjoyed watching, and like, subscribe, and we'll see you the next time.